Hello guys. So this video is for day 7. Day 7 is going to be on naming acids and bases. We're going to do a warm-up in class today, but I'm not going to go over it in the video. We're going to do it together in class. So today for B day is going to be Thursday the 21st. Day 7 for A day will be Wednesday the 27th. So that'll be next week. All right, so today is on naming acids and bases. So this is our last little bit of Unit 5. We have finally come to the end of this unit. Okay, so here's our warm-up. The first 5 questions, we are to write the formulas for the following. All right, so make sure that you are looking at polyatomic ions. Okay, so this is a polyatomic ion. This is a polyatomic ion. That is it for the first 5. This is the charge of the metal. Remember, if it's IDE, it's just an element. So this is iodine. This is lead, which is Pb. Tungsten is the symbol W. That's the charge of +8 on that tungsten. This is carbon. This is a covalent compound. Two nonmetals. This is a covalent compound, 2 nonmetals. This is a polyatomic ion. This is called phosphate. This is not carbonate. This one right here is not carbonate. Okay. This is a polyatomic ion here. This is called hydrogen carbonate. These 2 here are covalent. Okay. So just some tricks there. The first 5, we're going to write the formulas. Make sure they're charge balanced. So this one needs to be charge balanced. This one needs to be charge balanced. All of these that I'm putting a star next to need to be charge balanced, okay? And then these are ionic. These need to be charge balanced. Those 3. So 3 on both the first half and the second half. Those need to be charge balanced, okay? Then we're going to use prefixes for this guy. Use prefixes for this guy. All right. Mono, di, tri, tetra, penta, and so on are prefixes that we learned. Okay. So day 7, our learning objectives are that students will be able to define and name acids, define and name bases. We won't talk a whole lot about what these are, but we want to introduce what they are so that we can name them. So we'll define them and learn a little bit about them, but not much. There'll be a whole unit at the end of the year with acids and bases if we get to cover it. Okay, and that's typically where I end up at the end of the year is acids and bases. It's one of my favorite topics. Continue practicing, and that's a typo there, continue practicing naming compounds and writing formulas for ionic covalent compounds. So that's the point of the warm-up. And I know we get tired of these, but they help us practice this stuff. So we definitely want to continue practicing. All right, so acids. Acids are defined as substances that make H+ ions in water. Okay, so what that means is that if I have a solution, if I have an acid, okay, and I put it in water, I put it in a cup of water, what it produces in solution is ions of H+. So it produces H+. Okay, and then pH is a measure of the acidity. Maybe you've heard the term pH, like an acidic pH. Acids are covalent compounds. Even though they have an H+ with an ion, they're still considered covalent compounds because they're held together by covalent bonds. Okay, we have a special way to name them. We name them differently than we do other covalent compounds. So with other covalent compounds like CO2, right, we call that carbon dioxide, we use the prefixes. We don't use prefixes for acids, okay? Nor do we name it with simple polyatomic ion rules, okay? We have our separate set of rules for acids. All right, if we have an acid and let's say we named acids based on our rules that we've already learned, this is what they would be called. So HCl would be called hydrogen monochloride, which is not correct, okay? HF, we would call that hydrogen monoiodide. That's not correct. And as you can tell, these sound weird. Now H2SO4, and these should be subscripts, so it should be H2SO4. This guy would be dihydrogen monosulfur tetroxide or dihydrogen sulfate, and none of that is correct. Okay, so these are acids. So obviously the first thing that we're going to need to put in the name for these guys is at the end of the name, we're going to put acid. So if you see an acid, when we write the name of the acid, whatever his name is, we're going to make sure that the end of his name is acid, because we want to make sure that people are more careful with these substances because they're pretty dangerous, right? So we want to make sure that we have acid in the name. All right, so like I said, these are incorrect here. So we're not going to use those. And here's the correct names, okay? And I'll show you guys how to get these names. So HCl is hydrochloric acid. Chloric for the chlorine. And notice the ending in acid. Notice the ending in ic. We have HF, which is hydrofluoric acid. This is fluorine. Again, it ends in ic and acid. We have H2SO4, which is sulfuric acid. This is the sulfate molecule. And so we have hydrogen with that sulfate molecule makes this. Notice that it does not have hydro in front. So the rules that we're going to talk about is like, do we use hydro or not? What's the ending? Okay. All right. So the first kind of acid is called a binary acid. And basically it just means that it's two elements and one of those elements is H. So you have H and something. Okay. All right. So if you have HCl, instead of calling it hydrogen chloride, which is what we would call it, we're going to say, okay, the beginning of it starts with hydro. Anytime you have H with some kind of nonmetal, not a polyatomic ion though, but some kind of nonmetal like chlorine, fluorine, iodine, and bromine, these are the pretty common binary acids. There's others, but these are the ones that y'all need to know. When it's H with just a nonmetal, we're going to put hydro in front. So the hydro goes in front. Notice that there's hydro in front on all of these guys. And the hydro, yes, it means hydrogen, but in this case, in the naming, it means that it's a binary acid. So it means it's H plus something. So the hydro prefix there tells us that it's just H and an element, a nonmetal. Okay, chlorine, fluorine, bromine, iodine, whatever. Okay, and then we change the ending of it to ic. So instead of calling it hydrogen chloride, we call it hydrochloric. So instead of chloride or chlorine, it's going to be chloric. So it's going to end in ic. Okay. So HCl is hydrochloric acid. Hydro because it's hydrogen and a nonmetal, chlorine. Chloro because of the chlorine. The ic because we put the ending for ic for these acids. I'm not sure why. And then acid, so that we know that it's an acid. Hydrofluoric acid. Fluoro for fluorine. Hydro because it's hydrogen and a nonmetal, and then acid or ic acid. Iodine, so hydroiodic acid. Iodo is for the iodine. Bromine, so this is HBr, hydrobromic acid. So that's going to be for bromine. Okay, and then this is just saying that chlor is from chlorine, fluor, and so on. So when we name binary acids, which are acids that look like this, we always use hydro in front. So we use hydro in front of the name if it is hydrogen and a nonmetal. And then all we do is change the ending to ic. Okay. Okay. Pretty simple. Here are some other ones. If the formula for the acid has the polyatomic ion that ends in 8, like this one, this molecule right here is called nitrate. Okay. What we're going to do is we're going to change that 8. We're going to change it to ic. And a good way to remember this is I ate it because it was icky. Okay, and I know that sounds kind of funny, but that's an easy way to remember it. I ate it because it was icky. It means that if it ends in 8, we change it to ic. Okay, and it's kind of stupid, but sometimes that works, right? Sometimes stupid helps us remember things. So HNO3, nitric acid. So that is nitrate. Okay, and so we just changed the 8 to ic. There you go, nitric acid. So nitrate turns into nitric. Okay, this is the chloric. This is chlorate. This molecule right here is called chlorate. We change the 8 to ic, and then we get chloric acid. And this boxes here are supposed to be arrows, but sometimes the format does that sometimes. It erases my arrows and it puts boxes. It's annoying, but it does it. Next one. This is called the acetate ion. And we're going to change it to acetic acid. So we're going to get acetic acid there. Okay. Yeah, C2H3O2 is called acetate. So you just got to identify what this part is. Ignore the hydrogen. All acids have hydrogen. So just look at this part and say, okay, what is that ion? That ion is called acetate, so we call it acetic acid. You change the 8 to ic. This is phosphate right here, and so we're going to turn that to phosphoric acid. This one's actually in your soda. It helps keep your CO2 dissolved so that you keep your bubbles and your carbonation. There's also carbonic acid, which is why we call it carbonated. H2CO4, so that's sulfate right here. Sulfate turns into sulfuric, so that's sulfuric acid. All right, so I ate it because it was icky. So these are the icky acids. That's what I like to call them. Notice that there's no hydro. Okay, we use hydro something ic acid. We use that if there's only 2 elements. Notice in every one of these examples, there's more than 2 elements. There's a polyatomic ion. So these are not hydro acids. These are just ic acids. Nitric, chloric, acetic, phosphoric, and sulfuric. All right. Now, if the ion has ite, okay. Sorry, guys. My wife needs something, but I'll try to finish this up. So if the formula here has an ion that ends in ite, like this is called the nitrite ion, this is the chlorite, this is the phosphite, and the sulfite ion. Okay? And so if it has phosphite, if it ends in ite, we change it to us. Oh, and I forgot to change this. So this should be Sprite is delicious. Okay, so this is a cool way to remember it. Sprite is delicious. Ite to us. And again, it's stupid, but it works. It helps my AP students, at least. So Sprite is delicious. Sprite, ITE, to us. And so if you see the name, the formula, and it's got nitrite, chlorite, phosphite, sulfite, we change the ending of those to us. So instead of nitrite, it's nitrous. Instead of chlorite, it's chlorus. Instead of phosphite, it's phosphorus. Instead of sulfite, it's sulfurous. Okay, so these are other kinds of acids. No hydro, no ates. So these are called ite acids, and you just change the ending of ite to us. Okay, now let's look at bases. Bases are the opposite of acids. They are ionic compounds, and they simply have the hydroxide ion in them. So it's something, some kind of a metal, and a polyatomic ion, but in this case, the specific polyatomic ion we need is hydroxide. And if a compound has hydroxide in it, we call it a base. Some of these are pretty strong, some of these are pretty weak. They're the opposite of acids. They taste bitter. They're common in soaps, and we'll learn more about bases later. So when we name them, we name them just like we would any ionic compound. We write the name of the metal first. So this is NaOH. So Na is sodium. So we just name the metal first. Lithium, calcium, magnesium. We don't do anything different there. And then we just say hydroxide. So NaOH, because that's the name of that compound, OH. That's the name of that polyatomic ion, is hydroxide. And so that's sodium hydroxide. So NaOH, sodium hydroxide. LiOH, lithium hydroxide. Calcium hydroxide, and magnesium hydroxide. So these are real simple. Now the numbers do change, and that's because of the charge balance. So remember, sodium's a +1 because it's a group 1 metal, and hydroxide's a -1. So that's why it becomes NaOH. So when you write the formulas to these, you do have to make sure that the charge is balanced. Lithium is a +1 because it's a group 1 metal. Hydroxide is a -1 always. And so that's LiOH. 1 to 1 equal and opposite charge, right? Both teams have a 1 charge, or both teams have a score of 1, and you want them to have the same score. You want a tie. Now calcium hydroxide, calcium's a +2. So you're going to need 2 hydroxides to balance that charge, right? Because that'll give you a +2 and a -2. So we're going to end up with CaOH2. All right, same thing with magnesium hydroxide. And the same thing for any group 2 metal hydroxide. You're going to need 2 of those hydroxides. Now, aluminum hydroxide looks like this. And that's another one you might see. Aluminum hydroxide has 3 of those because aluminum is usually a +3 charge. Okay, that's about it. Now, I want you guys to do these on your own using the notes that we just did. Here's some guides. If it's H in a nonmetal, like this one, it's a hydroacid. If it ends in 8, like this one, then it is an ic acid. So that first one is a hydro something ic acid, and we use the nonmetal to do that. This next one is an ic acid, so this is just something ic and then acid. This is a base. This is an 8, so sulfate. Just change the ending to ic, so it's going to be something ic acid. Like I said, I'm just kind of trying to get you guys here most of the way. This is perchlorate. So we're going to change that to ic. Okay. All right. So these we're going to name them. Okay. So I'm giving you the formulas. I need you to name them according to what we just discussed. And then these we're going to write the formulas. Okay. So let's look at these. This is an us, which means that it was an ite. So if it's nitrous, that means that it had nitrite in it. And nitrite is in O2 with the -1. So just put hydrogen with that. Okay. Phosphoric, that means that it was an 8. So that's phosphate. Okay, which is PO4 with the -3. Just put hydrogen with it and make sure it's balanced. Hydrogen is always a +1. Okay. All right. Hydroiodic acid is hydrogen and this element, which is iodine. Hydrogen and iodine. Okay. But use the symbols, write the formula. Lithium hydroxide, that's lithium and hydroxide. Hydroxide is OH, the -1. Lithium is a +1. So write the formula for that. Hydrochloric acid, that means hydrogen and chlorine. So just write the formula of those two together. Okay, make sure you guys do the warm-up. We did that together. Make sure you guys do the exit ticket. Okay, instead of an ed puzzle, I'm going to give you guys an exit ticket, which is these 10 questions. I kind of showed you how to get them started, but I didn't give you the answers. So please finish them. And there's no ed puzzle today. I wanted to not do an ed puzzle today. So make sure you guys do the warm-up and the exit ticket, and you'll be all set. The next time I see you guys will be next Tuesday, and we'll be taking our test on this unit. So we'll finish this sucker up. All right, thank you guys so much.